For those of you who don't know me, I've worked at NI for a really long time. I just had my 25-year anniversary at NI. Most of that time I was in LabVIEW R&D, but for the past several years I've been in the technical support organization helping NI figure out how to support LabVIEW customers better. How many people in the room, this is your first NI Connect? That is so great, so glad to see you all here. I've presented at NI Connect or what we used to be called NI Week, for 25 years now, basically, since I started working here. And yeah, I gave this presentation last year. If you were here last year, those of you that did not raise your hand and you saw my presentation last year, go watch something else because this is the same presentation I gave last year. Also, I just want to mention, feel free during the presentation to ask questions. If you do raise your hand, someone will bring a microphone to you and you can ask your question, I can talk about them. But yeah, let's go ahead and get into DQMH. Before we get into DQMH though, for those of y'all that saw me this morning, you saw this slide. I present on LabVIEW a lot, and all of my LabVIEW presentations that I give personally are available at dnat.org, including the one that you're watching right now. So if you want to see a wide variety of LabVIEW topics and what I feel about them, go to dnat.org. There you will see links to be able to download slides, to be able to download demos, to be able to download or go over to YouTube and watch recordings of all of my presentations. In fact, the link for this one is at bit.ly/dnat DQMH intro. And another thing you'll see on the slide is that download link for Zoom It. So throughout my presentation, I'm going to be doing things like zooming in on my screen, interesting things on my screen, drawing boxes around those things. If you ever give presentations, you need to be using this tool. This tool is very easy to use. It's a 1-second download and a 1-second install, and you've got it on your machine. And it does a whole lot of crazy stuff. I don't do all the crazy stuff. I literally zoom in and draw boxes, basically what you just saw. And it really helps when giving a presentation to highlight things that are on the slides or that are in the code. So if you want to download my slides, or you can just go to Google and search for Zoom It. It's a Microsoft tool that you can download from their website. But you'll see that I'm going to use that frequently during my presentation. So you came here today to learn about DQMH, and DQMH is a LabVIEW framework. And since we're going to be talking about frameworks, I'm going to be using a lot of terminology. And I figured it was probably important to very specifically define the terminology that I'm going to be using throughout this presentation. There are going to be some terms in here that the definitions are rather subjective. Some people may not agree with me personally on how I define these terms. That's okay. I just want to make sure y'all know how I'm using them for the rest of the presentation. So, several terms to define. I'm going to be using the term process a whole lot during this presentation. When I say process, I just mean continuously running LabVIEW code. And if you've worked with LabVIEW before, hopefully you have, you know that continuously running LabVIEW code is basically a while loop, something inside of a while loop that's running over and over again. So when I use the term process, I'm talking about something that's in a while loop. I'm also going to mention reentrancy a few times if you're not familiar with that topic. It is the ability to take a piece of LabVIEW code and have multiple instances of that same code run at the same time. I'm also going to use the term API. Since I'm not a computer scientist, I'm probably using this term wrong. But when I say API, I basically refer to a group of functions that are related in some way. So in the screenshot, you can see I've got the file IO API, open, read, write, close file. I've got the TCP API, create, read, write, TCP, et cetera. When I say API, I'm just referring to functions that are related, that are grouped together. Usually find them on a palette in LabVIEW. I'm also going to use the term business logic. When I say business logic, I'm referring to code that you're writing that is specific to whatever application you're working on right now. For example, later in the slides or later in the presentation, I'm going to show one of the CLD exams that you write an automated teller machine, an ATM. And when you're writing the code for an ATM, you might have some code that is, looking up somebody's name in the database and figuring out what their balance is, or withdrawing some money from their account. That is business logic. That is code that pertains specifically to the using of an ATM. In other words, it is not framework level code. So if you've got some sort of LabVIEW framework, actor framework, DQMH, something that you wrote, whatever, the framework that's facilitating the application, that's not business logic. The code that's withdrawing $50 from somebody's account, that's business logic because it has to do with the specific application we're working on. Got some more terms I need to define. I need to define the term synchronous. So when I refer to a synchronous process in LabVIEW, I'm referring to something that has to happen in a certain order. So if you look at the slide, you'll see that process B cannot happen until process A is done, and then process C will then happen when process B is done. That's a synchronous process. Those things have to happen in that order. Compared to an asynchronous process, where you can have the processes running independently. So in the screenshot here, you see that process A, process B, process C, in LabVIEW, there's no data flow between those three processes, so they're all going to run independently. I'm going to be talking a lot about queues. Queues are an API in LabVIEW that let you pass data between processes. So you can see we have the two independent processes, the while loops, on the screen. You can see that the top loop is able to enqueue data into that queue, and the bottom loop is able to dequeue data from that queue while those two loops are running independently. So we have an API that can pass data between them. And guess what? Events are exactly the same thing in the terms of what I'm going to talk about today. Events are another LabVIEW API that allow you to pass data within a process or between processes. In the case of what you see in the slide, now the bottom loop is going to be firing events that the top loop is then going to consume. And those two loops, since they don't have data flow dependencies, can run independently. So that's a way for us to pass data between them. One more slide of glossary. I'm going to be referring to design patterns in LabVIEW. And this slide, the terms are, this is my most contentious definition because there are probably some of you that might not agree with my terms, but these are how I'm defining these terms today. A design pattern is a theoretical mechanism. It is something that, in theory, you could use to execute synchronous or asynchronous code. The prime example is a producer-consumer. That is a theoretical mechanism where you have a process that is producing information and a process that is consuming information. If we take the next step, we can then talk about an architecture, which is something in the real world, so not theoretical, but something in the real world where we take one or more design patterns, which are theoretical, and actually use them to facilitate execution of asynchronous code. And typically they're templatized. So if you think about like the JKI state machine, I would say that that's an architecture. You drop that on a block diagram and there's comments in the code that say, add your code here, add your code here. It's a template. And then we get into frameworks. So in my definition, a framework is a consumer grade architecture. So we've got an architecture, so some way to develop an asynchronous based application, but it's an architecture with documentation. It's an architecture with tooling so that you as the LabVIEW developer using this framework don't have to manually write all the framework code. And in my estimation, there are 4 publicly available consumer grade frameworks in the LabVIEW world today. And those are DQMH, Actor Framework, JKI State Machine Objects, and as of very recently, I found out about all the tooling that had been added to a new framework called Workers that I believe also constitutes being a framework. So those are the 4 big ones. Those are the 4 that are publicly available. Those are the 4 that you can download on VIPM, or in the case of Actor Framework, already comes with LabVIEW. But today we're going to be talking about DQMH specifically. Now, of those 4 letters, 3 of those letters are QMH, which stands for Queued Message Handler. So I feel like in order to talk about DQMH, I first need to talk about QMH, and more specifically, the NI QMH, the one that ships with LabVIEW. So as I use that acronym, Queued Message Handler is what I'm referring to. So the NI QMH has been in LabVIEW for a long time. It was introduced in LabVIEW 2012. I wrote it. Now, I didn't write the QMH because QMH has been around for forever, but in terms of the codified NI1 that comes with LabVIEW, we added that in 2012. And this is what it looks like. So if you've never, hopefully most of you have seen a queued message handler. Hopefully most of y'all are somewhat familiar with a pattern that looks like this, where we have a top loop and a bottom loop. And the top loop is what we refer to as the event handling loop. So that's the loop that's going to do things like respond to clicks on the front panel or whatever. If there are any custom user events that our application uses, that loop is going to reply to those. And then the bottom is what's called the message handling loop. So the bottom loop grabs onto whatever's stuck into the queue and decides what to do about it. And that's usually just a case structure that's driven by whatever message is in the queue. This is the NI QMH. And more generally, this idea of having a way to produce messages that a loop consumes, that general idea, to be honest with you, is the basis for all LabVIEW frameworks. So Actor Framework at its core is actually a queued message handler. Even though it doesn't look like that, that's how it behaves. So Another project template that ships with LabVIEW is the Continuous Measurement and Logging Sample Project. This is a project that is supposed to be basically a real-world application where you can acquire data, log data, display data, and it's built on the NIQMH. You can see the top half of this diagram looks just like the one I showed on the previous slide. It looks just like the NIQMH. You've got an event handling loop, you've got a message handling loop, but the Continuous Measurement and Logging Sample Project also adds a couple more message handling loops. It adds one for acquisition, it adds one for logging, and one of the interesting things is, I'm gonna zoom in a little bit here, and I'm gonna show that this VI right here creates the queues. In this case, we've got an acquisition queue, a logging queue, and a UI queue. And you'll see that that cluster of queues is passed into the acquisition message handling loop, and that cluster of queues is also passed into the logging message loop. So any message handling loop in this code can send a message to any other message handling loop. There are some problems with this design. This is a very popular design because it's a pretty easy design. We give you a template for it in LabVIEW. With the click of a button, you can start with this code instead of a blank VI. So it's used a lot. The queued message handler is used a lot, but there are some problems with it. First of all, communication between the processes. I just showed y'all on the previous slide that this cluster of queue wires is passed everywhere. So anybody has access to anybody else's queue. What if you add another message handling loop? So we've got the UI, we've got acquisition, we've got logging. What if we need to add a database message handling loop? So we want to start storing our data in a database. So now we have to then make a new VI. We have to add the queue reference to all those other queues. We have to add it to the thing that we're passing around. Now all these other guys have access to that queue. As you start adding more processes to your application, more things that need to run asynchronously, you're having to basically change the data structure that everybody else is using. And it's difficult to debug when any process in your entire application can send a message to any other process in your entire application. If you've got a process that's not working properly because it got a bad message, well, where do you start? How do you figure that out? Anybody could have sent that message. So that can make things very difficult to debug. Also, this design, the NIQMH, having this cluster of queues, it really limits our reusability. Right now, in the code that I just showed, the acquisition message handling loop has a reference to the queue of the UI loop so that it can say like, hey, go abort if something goes wrong with the data acquisition. Well, let's say I've got another application where I want to have an acquisition process. Well, I can't just take this one and copy it over here because it's got pieces of it that relate to the application that it's currently sitting in. It's not independent, it's not reusable. Also, let's say we wanted to configure multiple devices for acquisition. So we had one DAC device, now we want to add a second one. I guarantee you if we just make the acquisition message handling VI reentrant and try to drop a second copy of it, things aren't going to work right. But probably the biggest annoyance for me with the NIQMH is that anytime you need to make a change to the framework level or architecture level code in your application, you have to do it manually. I just mentioned several times, you would have to add a new queue for this new loop. You would have to create the new message handling loop VI yourself. These are all things that you have to do manually. And anytime you need to manually create new case structure cases for a queue or manually create new user events, if you're firing events, things can become error prone because you may type a case name wrong, or you may forget to add the close reference code for this new event that you added. There's all sorts of things that can go wrong if you try to make framework level changes manually to your code. With all of that background, let's start talking about DQMH. Now that I've sort of identified why there are some things that we may want to improve to this whole QMH idea. So here's a little history. DQMH has been around for 9 years. In 2015, it was originally developed by Delacorp, which is an NI Alliance partner. If you've ever wondered what the D in DQMH stands for, it stands for Delacorp. And Fabiola de la Cueva, who's the chief architect of DQMH, and Delacorp's her company. A year after it came out, DQMH was awarded the LabVIEW Tools Network Product of the Year. A few years after that, Delacour created the DQMH Trusted Advisors Program, which is basically a group of people who have been identified as being DQMH experts who are able to provide assistance and development who we can trust know the best practices of DQMH. And then in 2021, ownership of DQMH transferred over to a nonprofit called the DQMH Consortium. Their website is dqmh.org. And then as of today, the latest version of DQMH is 7.01, which you can download on VIPM. So if you go into VIPM or go to vipm.io and search for DQMH, that's where you get it. It's free to download, free to use. And as I've described already, DQMH is a framework for facilitating large application development. A large LabVIEW application is typically going to have multiple asynchronous processes running in parallel, and DQMH is a way to very easily facilitate the development of that type of application and all the communication between those processes without you having to figure all that stuff out yourself. It is, by a lot of measures, the most popular third-party framework for LabVIEW in the world. One of those measures is the fact that I'm pretty sure DQMH is the only third-party product that NI offers a certification badge for. It uses the same scheme as NIQMH for communicating within a process, which is a queue. The QMH, obviously, that's what the Q stands for queue. And within a process, DQMH uses a queue to communicate. But if you've got a DQMH process here and a DQMH process here, and they need to communicate with each other, that's where DQMH is a little bit different than some other frameworks. It uses user events to communicate between those two things. If you've never heard of user events or never used user events or are a little scared of the idea of user events, don't worry. When I show my demo of the code, you're gonna see that the DQMH tools abstract away all of that stuff for you. You have to write exactly 0 user event code when using DQMH. Probably the biggest draw of DQMH, and one of the reasons that it is so popular, is that the fact that DQMH was designed by Delacour to be accessible to CLAD and CLD-level LabVIEW programmers. There are some other LabVIEW frameworks that have a steeper learning curve. A lot of the times that has to do with the fact that LabVIEW classes are a core component of some LabVIEW frameworks, which makes sense. LabVIEW classes are a powerful tool in LabVIEW for object-oriented programming and for dynamic dispatch. They really lend themselves to framework development. Unfortunately, they can also be difficult for some LabVIEW programmers to grasp and to really feel comfortable with. When you program a DQMH, you don't use classes at all if you don't have to. The framework itself, it does use some classes, the framework does use some classes, but they're not parts of the framework that you interact with. So in terms of using DQMH, it's designed to be very easy for CLAD and CLD level LabVIEW developers. So, sorry, I got another glossary here. I really need to define some terms so that we're all on the same page. One of the things I'm gonna be saying quite a bit is a DQMH module. So DQMH module is the basic building block of DQMH, and it basically is what wraps the asynchronous process that we're talking about here. So if you had, if we go back to the continuous measurement example where you've got a UI and you've got acquisition and you've got logging, if this was a DQMH-based application, you would have a UI module and a logging module and an acquisition module. And a DQMH module is just a LabVIEW library. So that's something to keep in mind. And you can have a module that can run just standalone, which we call singleton. You could also have a module that you can spawn multiple instances of, which we would call clonable. All right, you have your module running. Let's say it is your acquisition module. And let's say you want to tell the acquisition module to start acquiring. Well, you can't tell it to, but you can ask it to. So that's one of the ways you can communicate in DQMH is by sending a request. A request is a way to ask a DQMH module to do something. I guess in the screenshot, we've got another example here. If we have a timer module, which, spoiler, I'll be writing a timer module later, we can ask the timer module to start. Please start for the specified duration. That's a request. You're asking it to do something. And then we also have broadcasts. So broadcasts are a way for the DQMH module to tell the world something. So if we go back to our timer example, we have a request where we ask the module to start timing. We can have the module broadcast out to the world to say, hey, I'm done timing. The timer has elapsed. If you remember nothing else from my talk today, remember this slide because this is the basics of DQMH. This is what you need to know to be able to carry on a 2-sentence conversation with somebody about DQMH. Modules are libraries that wrap asynchronous processes. Requests are ways to ask modules to do something. Broadcasts are ways for the module to tell the world something. All right, so in your module, you're gonna have a main VI, which is basically gonna be the QMH of your module. Then there's something in DQMH, which I'm gonna demonstrate in my demo, called the API tester, which is a way for you to test that your module is working properly. This is one of the best parts of DQMH. This is one of the reasons it's so popular, is because the framework has built-in debugging and testing capabilities for you out of the box. And then what makes DQMH framework a framework are the scripting tools. There are no manual changes you have to make to framework level code in DQMH. Remember I mentioned before, user events are the way that modules communicate with one another. You are going to write 0 user event code with DQMH because the scripting tools are going to take care of all of it for you. Create a new module, rename a module, create a new request, create a new broadcast, rename a broadcast, delete a broadcast, all of that stuff. You're not going into VIs and deleting a generate user event function. You're running the tools to say, oh, I don't want this one anymore, or I want to rename this one. It's all tool-based, and that's one of the great things about DQMH, probably the best thing about DQMH. All right, so I can't believe I'm gonna have to stand up and write LabVIEW code. That's kind of annoying. Usually I'm at my desk, right? But I'll try. I'm going to write a simple DQMH module for you guys from scratch to just sort of, and again, this is the introduction to DQMH, just to sort of illustrate how you would go about creating a module. And the module we're gonna create is a timer module. So this is gonna be a very simple module. Basically imagine like a stopwatch, or no, I guess not a stopwatch because they keep going. It's gonna be like setting a countdown timer. That's what it's gonna do. You'll be able to start the timer for a specified duration. You'll be able to stop the timer. And the timer is gonna broadcast out if it has elapsed. I'm not gonna add like pause or the complicated stuff. I don't have time for that, but I'm just gonna, real simple, start, stop, broadcast. We're gonna create the timer, and then I'm going to talk about how that would then be integrated into a larger application. So we are going to create a DQMH module from scratch. So I have an empty project here, and I'm gonna create a timer module in this project. So I'm gonna use the DQMH scripting tools to add a new module. We're gonna call it timer. We're going to say this is a simple timer with start and stop. We should probably give the library a nice banner icon. So we'll say timer, and we'll make it nice and bright red. And that's it. So we're going to, LabVIEW is going to script the new module into our project. And when it's done, we're going to have the module library, like I talked about before, which is your module. And then we're gonna have the tester as well. So the first thing I'm gonna do is I want to go ahead and create those requests and broadcasts that I talked about. Remember, for this timer, we're gonna have 2 requests, one to start, one to stop. And we're gonna have 1 broadcast, which is the timer telling the world that the timer has elapsed. So let's go ahead and create those requests now. So I'm, again, going to the DQMH scripting tools and creating a new event. And we're going to create the start timer module first, or request. Start the timer for specified duration. And one of the things I'm going to need to tell the module is how long I want the timer to go, right? So let's create an argument, which is duration. Okay. So the scripting tools are gonna create that new request. And the very first thing we see here is not actually the module. What we see here is called the tester. So this is part of DQMH, which is a way to always be able to test your code. And I'm gonna illustrate why that's important later. But I have the tester for my module. So before I do anything else, I'm actually gonna write the tester code for this new request. I'm not gonna write the business logic for starting the timer. I'm gonna write the code that lets me test the timer. That's the first thing I'm gonna do. And notice, this is what DQMH told me should be the first thing I should do, because this is the window that is open after I made the request. So I'm gonna go ahead and create the duration control, and remember, this is my tester. This is not my module. So now I have a way to test starting the timer. Now let me go ahead and create my next request, which is the stop timer. So we will call this one stop timer, stop the timer if it's running. And once again, the tester is gonna come up, and that's the first thing that I'm encouraged to edit. So I'm gonna come over to the front panel and move this button over here. So that's my 2 requests, start timer and stop timer. The last thing I need to add, then the last event I need to add is a broadcast to tell the world that the timer elapsed. So last time, we're going to create a new event. This time we're going to create a broadcast. We're going to say timer elapsed. And once again, the tester is put front and center. Hey, make sure you test this new code you added. So we'll get rid of these comments here, and we'll make a really simple status message that says timer elapsed. Our tester is done. We are ready to test our module. But if you're paying close attention, you may have noticed I have not actually written the code to run the timer yet. So I should probably do that, right? So let's go over to the actual module, which is here. So this is the main VI of the DQMH module that I created. If I scroll up and down, you might notice some familiar things like an event handling loop and a message handling loop. So if you have worked with the NI-QMH before, this should be a very similar pattern. Another thing that's very common in queued message handlers is the data cluster for your module. So I'm going to open that up, and I'm going to add a few controls to the data cluster, like whether the timer is enabled, and what the duration is, and what the start time is. So again, if you have worked with QMHs before, this is a pretty common pattern. You've got that cluster that you pass around in your QMH. So when we initialize our timer, we want to make sure that all of those values have good values, or all of those parameters are set to good values. Not enabled, default values for the duration and start time. And I'm going to start with some easy code first, which is stop timer, because stop timer is basically just going to reset all of those. So I'm going to put that in there. What I'm doing right now is writing the business logic for my timer, just to go back to some glossary stuff. And then to start the timer, by the way, you may have noticed that those frames are already added for me for start timer, stop timer. That's because the DQMH scripting tools added them for me. I'm going to go ahead and set the duration and the start time. And one of the things about queued message handlers is a queued message handler can message itself. So that's exactly what we're going to do here. For the purposes of our demo, I'll say that if I was writing this in the real world, I would use something called a helper loop, which is what I won't be talking about today. But in this situation, we're just going to write some really quick and dirty, honestly, queued message handler code to have the message handler message itself to check the time. So I need to add that frame to check the time. All right, so we're almost done here. If you guys don't enjoy watching live LabVIEW coding, I'm almost done, don't worry. Okay, so we need to basically add the business logic to what do we do when we want to check to see if the time has elapsed. So we're going to go ahead and add that here. And let's see, pass this error wire through. Okay, so we want to take a current timestamp and subtract the one that we stored at the beginning. And we want to see if that is greater than or equal to the duration that we've set for our timer. And if it isn't, which would be the false case, then we want to run this code again. We want to check the time again because the time hasn't elapsed.
You want that all in the false case?
Pretend you didn't hear that, everybody. Of course, it was Putnam that had to say that. Okay, so we'll go ahead and say, let's wait.
Oh, you're testing. Okay.
Yes, he's saying out loud what I didn't want him to say. Okay, so this is the case where the timer hasn't gone off yet. We need to go ahead and check the time again. But in the case where the timer has gone off, look, the DQMH scripting tools gave us handy access to our timer elapsed VI, which is a broadcast. And at this point, we need to tell the timer to go ahead and turn off. We don't need you anymore because you have elapsed. All right, and I think one more thing that I'll add to my code is, even though we're not using the front panel of this module, look, there's nothing there that's interesting. I'm gonna add a debugging indicator on the front panel in case we ever have to see what's going on with this module running. And that's just gonna be the current time that we have set. So let me make this guy a little bit bigger for the purposes of everyone seeing it. And then, okay, I think I'm pretty much done here. I got my business logic written. So let me run my module with my tester. I'm gonna click Start Module. I'm gonna set a time to 2 seconds, and I'm gonna click Start Timer. And we should see that after 2 seconds, a message pops up that says the timer elapsed. But we didn't see that. So in typical engineer fashion, I'm going to click it again just to make sure. All right, so something's wrong with my code here. I made a mistake while I was writing the code, pretend that Putnam didn't notice it. And we need to go figure out what I did wrong, right? So the first thing I'm going to do is I'm going to show the panel of the module, which remember is not normally needed, but I'm showing it for a debugging tool. And let's move it over a little bit. And I'm going to click Start Timer, and we see that my time isn't even updating. So something is wrong in the logic in my code. So let me show the block diagram of my code while it's running. Notice that all of these buttons, Show Panel, Hide Panel, Show Block Diagram, those were built into DQMH for me. Those are built-in debugging tools. I did not have to create them. Those are there for me. So I'm going to show the block diagram of my code. And let's see, maybe I'll check to see if that Boolean, that enabled Boolean, did I accidentally set that wrong? So let me go back to the tester and click Start Timer. We can see that enabled is true. So my timer's enabled. So once again, let's go back to the block diagram. So the timer's enabled, but then now I see what the problem is. As Putnam noticed, I accidentally put all of my business logic in the false case of my case structure instead of the true case. So I made a mistake in my code. The DQMH debugging tools allowed me to find that mistake. So now let me go ahead and stop the application, go in, make that change. We'll change this to the true case. And let's try one more time. So we'll run, we'll start, we'll show the panel for debugging just in case. We'll set the duration to 2. We'll start it. Now we see the time is updating and we see timer elapsed in the status indicator. So thanks to the DQMH debugging tools, I was very quickly able to narrow in on the problem that I had and go ahead and fix it. Now, when I gave this presentation at NI Connect last year, someone in the audience asked a question. They said, okay, that's great. You wrote a DQMH module. It can do a timer. And they thought that at this point, what they would need to do is drag all of this business logic code somewhere to use their timer. And that's the point where I realized I did a poor job explaining what you're supposed to do with DQMH. Because the whole point is that this DQMH module abstracts away the business logic for running a timer so that all you need is the VIs to start the timer and stop the timer. That's all you need. It's kind of like when you use the file functions and you do write to file. Do you open the write to file primitive and copy the C code out of it? No, you just use the write to file function. Same thing with DQMH. You're just going to use the public API for the module. So let me illustrate how you would do that. So this is just the timer module. That's all I wrote here. We tested it. It worked. Now, let's see what it looks like to use the timer module in a larger application. I'm going to close a few windows here. I'm going to switch over to the CLD ATM exam. So this is one of the sample exams for taking the Certified LabVIEW Developer exam, and they have you write an automated teller machine. And this is what the front panel of the sample exam looks like. You insert your card, you enter your password, you can do a balance inquiry, you can take cash out, you can do a balance inquiry. But one of the functional requirements of the ATM CLD sample exam is that if the machine is sitting there for 10 seconds and there's no interaction with the buttons or anything, it kicks you out and ejects your ATM card, similar if you were using a real ATM in the real world. And you can see that's what happened. When I was standing here talking, it went for 10 seconds without me doing anything. It ejected my card. Now, we need a 10-second timer in the ATM, right? I just wrote a timer module, right? It would be great if I could use that timer module in my ATM code, and that's exactly what I've done. So if we look at the block diagram, we can see, hey, that looks familiar. That is the start timer request for my timer module. So I didn't copy business logic out of my timer module. You don't see like the math that's doing the subtract of the timestamp to figure out. That's the DQMH module is taking care of that. I'm just calling the request to start the timer. And you'll see that in the event structure, we are registered for the timer elapsed broadcast. So if we zoom in here, so you can see that if the timer elapses, that event is going to fire, and then we terminate the application. What if I was working on my ATM, and I clicked around on the front panel, and I waited for 10 seconds, and nothing happened? The ATM did not immediately eject me out of the application. That means there's something wrong with my timer, right? Now, to debug that, should I have to run the entire ATM application to figure out what's wrong with my timer? I should not. I should be able to test the timer in isolation and figure out what's wrong with it. That's one of the things DQMH allows you to do. Build your code, test your code in isolation before and during integration with your main application. That's one of the biggest benefits of DQMH, and frankly, other LabVIEW frameworks as well, the ability to write modular code and testable code. All right, so this was an example of me integrating the timer into the ATM. And the ATM, like the main UI, you might also notice this is a DQMH module as well. Well, there are some frameworks in LabVIEW where it's very difficult to sort of mix paradigms. I'm not going to name any names, but there are some frameworks where if a framework is part of your application, it's very difficult for other parts of your application to not use that same framework. Well, in the case of DQMH, we don't really suffer from that problem because of the public API stuff that I talked about. So can anybody tell me what type of design pattern this block diagram is? I think I heard someone whisper state machine. Maybe it's because they just read in the upper corner of the diagram that it says state machine. This is a state machine, all right? This is something hopefully most of us are familiar with. You got the while loop, you got the enum, you got the case structure, very simple state machine. That is what this main application is, but this main application utilizes a couple of DQMH modules, and we can see on the block diagram, we can see a request VI right here. We can see another request VI right here. So we're utilizing the public API of the DQMH module inside of this state machine-based application. There's no problem with that. There's no problem calling DQMH VIs from wherever you want, just like there's no problem calling TCP functions or file IO functions or whatever from anywhere you want, because you're just using the API of the module. Are there any other questions on any of the stuff that I demoed before I get back to the slides?
Can it be used in a real-time application?
Can it be used in a what?
In a real-time application?
Real-time. So the question is DQMH compatible with real-time applications? The answer is yes. Everything that you've seen here, fully compatible with real-time. In fact, the tester VI, if I go back real quick and show you what that looks like. Here's my timer tester. You can see we've got things like configuration for value change events, which is not supported on most real-time targets. There is a scripting tool in DQMH called Create RT Tester, which allows you to create a tester VI for your module that specifically tests it on RT. Any other questions before I move on? See a question over here.
So on that same note, is there a way to communicate or make requests across boundaries like RT?
So the question is, yeah, so the question is, in terms of the communication that I've just showed, it's all user event based. Is there a way to communicate? A lot of times it's going to be over network boundaries and things like that for RT applications. One of the great things about DQMH is the ability to create a module based off of a template. If you had eagle eyes, you might have noticed that when I created my new module for the timer, I created one from a template called Bare Bones, which is one that has a bunch of stuff stripped out just because I wanted some simple code for you guys. There are some teams, some LabVIEW teams that have made publicly available DQMH module templates specifically for doing network communication in Windows and RT applications. All right, let's talk about developer roles. How are you interacting with DQMH? Are you a DQMH module developer? Like I just was when I wrote the timer module. I developed a module, and what that means is that I personally created the requests and broadcasts for my module, and I wrote the business logic that actually implements the timer. That is when you're in the DQMH module developer role. When you are in that role, a few things to keep in mind. Always keep your API tester up to date. You never want to be in the situation where you've written a module that has a problem, and then you go over to your tester and you forgot to write the code to test the requests and broadcasts, and now you have to go do that. You want your tester to always be ready to test your code. Also, there are a bunch of best practices involved with DQMH. Since this is an introductory presentation, I'm not going to go into all of those, but they're documented and available on the DQMH website. Never, ever make manual changes to framework VIs in DQMH. If you are editing some VIs and you get to a spot in the code where you're messing with the things wired to a generate user event function, you're doing something wrong because you are editing framework level code. So do not do that. DQMH does a pretty good job of putting a label on the block diagram of every framework level VI that says, don't mess with this code, you're gonna screw up the scripting tools. So follow the advice of those things. And the last piece of advice I have here, if you're developing DQMH modules, is to document everything. Did y'all notice when I did my demo that I wrote a description for my module, I wrote a description for my requests, I wrote a description for my broadcast? Was I wasting time? No, it's just so ingrained in me when I work with DQMH to document everything that I did that even when I was doing an NI Connect demo. One of the reasons that it makes a lot of sense to document everything is because there is a tool available called AntiDoc. It is a free tool. It is on the tools network, or I'm sorry, it's on vipm.io. I've got a link in the slides, or you can just search for AntiDoc. This tool will automatically generate project documentation for you. Descriptions of all your modules, descriptions of all your requests and broadcasts, and it makes this really cool diagram that shows the relationships between all of your modules. So in my case, in the ATM, I just had 3 modules. That's not that complicated. But this picture tells me so much useful information, just this picture. I see that ATM sends requests to timer. I see that timer sends broadcast to ATM. I see that ATM sends request and wait for reply to account manager. I see that account manager sends broadcast to ATM. You know what else that I see? No dependency between timer and account manager, which means those are reusable pieces of code that I can use in other places in my applications. And again, that diagram is generated for you for free. AntiDoc just looks at your code and spits out that picture along with the documentation of all your modules. Super useful tool. And then this goes back to the question I got asked earlier. DQMH comes with 2 templates. One is for singleton modules and one is for clonable modules, which are reentrant. Those are the only 2 it comes with. You all saw I used a bare bones template that I had created for my demo for you guys, but there's dozens of other DQMH templates out there. If you find that there are some patterns in the modules that you're writing for an application and you know you're gonna be writing a lot of modules, it makes sense to create a module template so that that's your starting point for all your modules instead of having to manually redo a bunch of things. Like if all the modules in your application need a certain set of requests and broadcasts, make a module template. Then every module you create is gonna have all those requests and all those broadcasts. All right, so that was DQMH developer. What if you're a user of a DQMH module? What if I wrote that timer module and then I gave it to you and said, here you go, here is a timer module that you can use in your application. Maybe you're writing the ATM and I gave you a timer so that you don't have to write one and so you can use my timer. If you are using a DQMH module, then you are using the public API of that module. You're using the requests like start timer. You're using the broadcasts like timer has elapsed. You are not looking at the business logic that I wrote. You are not copy pasting the business logic that I wrote. You are just using the public API of the module. And in those cases, hopefully I gave you a VIPM package that includes a palette of the public API of that module. Hopefully you don't have to go digging through my source code to find all the public API VIs of my module because I've given you a VIPM package that has a palette defined for the module. But if I didn't do that, you can still find reasonably easily what you need with the requests and broadcasts. The module LabVIEW is always gonna have a folder called public API that's gonna list all the requests. And then if you create an event structure and wire the module's event reference to it, you're always gonna see the list of all the module's broadcasts. Here I'm gonna zoom in on this a little bit. Just to illustrate that. So if you open the module library, then you see a folder, it's not zoomed in very well. You see a folder called public API requests, and those are your requests. If you are using a broadcast, you see that the broadcasts are listed in the event structure dropdown. So those are the ways you can get a hold of that information if someone hasn't given you a palette or other documentation. And then another easy way to learn how to use a module is to open up its tester. Hopefully whoever developed that module kept the tester up to date so you can see how the tester is using the public API of the module and then you can use it in a similar way. When I create a palette of DQMH VIs for a module that I've written, I always drop the tester in the bottom corner of the palette. So even though it's not something you would be dropping and using, you can then open it from there at least and then kind of learn more about the public API. So what are some benefits of DQMH? Why is it the world's most popular third-party framework for LabVIEW? It's the scripting tools. If you ask Fabiola about her framework, she's gonna tell you there's nothing special about the actual framework. Like the LabVIEW code in the framework, it's pretty standard. It's not that big a deal. The reason DQMH is so useful is because of the scripting tools. How many times did I have to write any user event code in my demo I did? 0. The framework is scripting all of that stuff for me. The framework also created a module for me that already had show panel, hide panel, show diagram, a bunch of stuff built in. And there's also a tool called module validation. So let's say you used an old version of DQMH to write some code, and from years ago. The current version of DQMH is version 7. And this is software. Software has bugs. DQMH has had bugs in it, just like any other piece of software, that have been fixed over the years. There's a tool in DQMH called module validation, where you can point the module validator at your module and say, hey, are there any bugs in DQMH that have been fixed since I created this module? And it'll come back and it'll say, yep, here they are. And it'll let you fix them with scripting code that you don't have to touch. So you click a button and say, fix my module, and it'll bring your module up to the latest version with no bugs in it. That is an amazing tool. Let's see what else. Another benefit of DQMH is the fact that QMH is a pretty familiar pattern. So if you had never heard of or seen DQMH before, and I created the timer module with the scripting tools, and I handed it to you, and I said, could you please fill in the business logic for starting the timer and stopping the timer and what happens when the timer elapses? You could probably do that because the queued message handler, it's templatized. We show you where to add your code. You don't have to be an architect to add code that subtracts timestamps and tells you something, right? So that's the fact that the QMH is a familiar pattern is really useful for developing with DQMH. And then another huge benefit, and this is one that one of my colleagues who writes a lot of DQMH code that he told me he loved about DQMH, is the fact that a lot of the stuff that can be painful when trying to write asynchronous LabVIEW code is already handled for you. When you ask the thing to start, it starts. When you ask it to stop, it stops. When you ask it to show its panel, it does. All of those things, when you ask it to report errors, it does. Those are all things that are built into the framework that you never have to worry about. Super useful benefit. There's a very active developer community on ni.com of DQMH programmers asking each other questions, asking each other advice, giving each other advice. And the DQMH consortium, who currently owns DQMH, is incredibly responsive to feature requests. The link in the slide is to the feature request forum on ni.com. And every release of DQMH has several feature requests from this forum included in it, because the DQMH consortium really, one of the first things they look for is what are other people wanting in our framework, and those are the first things they start with for adding new features. Bunch more benefits. Hampel Software Engineering is a company. They actually wrote the generic networking template that I mentioned earlier. They have a lot more benefits that they like to talk about with DQMH. All of their development, I don't work for them, but I talk to them a lot, and I'm pretty confident in saying that every project they work on is DQMH based. So they have a lot of advice to give on best practices and benefits. Let's see, how to learn DQMH. There are a lot of topics of DQMH that I did not cover today, including the ones in this slide and many more. Every one of those topics is covered in other resources related to teaching DQMH. There's even other tools. I did mention Antidoc. I did not mention Panther Dashboard, which is another really useful tool. These are all really useful topics that I just don't have time to cover in an introduction to DQMH presentation. So how do you learn about this stuff? Documentation is a good place to start. How to learn. There is a page on dqmh.org called How to Learn DQMH. And it lists several approaches, like if you prefer to learn from videos, if you prefer to learn from browsing examples, if you prefer to learn from in-person instruction. It lists all these different ways that you can learn DQMH. There's a LabVIEW programmer in the UK named Tom McQuillan. He is an excellent LabVIEW presenter, and he has a beautiful voice. It's just so lovely to listen to him talk about just about anything. But one of the things he talks about is DQMH, and he's got a series of videos on learning DQMH up on his YouTube channel. The DQMH consortium has also created videos on how to learn DQMH. There is a shipping example. So if you just kind of want to dig through some code and learn, you learn by that better than you learn by watching somebody else talk. The shipping example for DQMH, which simulates a thermal chamber, excellent starting place if you want to learn some of how DQMH works. And it's a very well documented example as well. And then of course, I have to mention, the DQMH consortium has an official training course, like an actual 3-day in-person course. And one of the cool things about their course is They ask you about your application needs before you take the course, and they tailor the course contents to what you're actually going to be using DQMH for once the course is done. There's another way to learn DQMH, and this is the way I provide. So there is a page on ni.com, and the link is here, bit.ly/DQMH learning path. This is a learning path that I put together. It is a one-day learning path. It is free. It's just sitting there ready for you to learn. A step-by-step path on learning the most common DQMH concepts. Remember I told you guys, what a module is, what a request is, and what a broadcast is. Those are the three things I want y'all to come out of this presentation knowing. Well, probably not going to be able to write a successful DQMH application only knowing those three things. They'll get you a start, but there's other things you need to know, like clonable modules, request and wait for reply, helper loops. There's a bunch of other topics. I cover all of those in my quick learning path. I forget how many steps at this point, 8 steps, 9 steps, I don't remember, but step 1 is watching this presentation. So you'll have already done that one. Then it's steps after that. Yeah, I also feel compelled to say it is not a substitute for the official DQMH training course, but it is free and it's just a day and it's my stuff. So you can check that out. Are there any questions on any of the stuff that I covered so far? I got a question over here if we can get a mic over.
So will the scripting tools allow you to change from a singleton module to a clonable module?
The question is, can you use the scripting tools to convert a singleton to a clonable? You cannot. It is one of the most requested features for DQMH. It is not there yet. It is on the feature request page. I can tell you it would be extremely difficult to implement, which is probably why they haven't done it yet.
So
now,
given that, is there a reason, would there be any reason to even use the singleton template versus just making all of your modules clonable?
We have a few minutes, so I feel I can answer that question. Yes, so the question often comes up. I am not a member of the DQMH consortium, but I work with them all the time. And they very frequently discuss the topic of why do we even have singleton modules in the first place? Especially because clonable modules have an option where you can run them as singleton. So you can actually tell a clonable module, hey, I want you to just run as a singleton, never run another instance of me. Why do we have singleton modules? One reason, singleton modules are incredibly easy to debug. Once you add the reentrancy layer in LabVIEW and you have the possibility of having multiple VIs that are spawned, the debugging tools in LabVIEW are just not as quick and not as straightforward as when you've got a non-reentrant VI that you know you can show its diagram and start throwing probes and everything's just gonna be there. It is much easier to debug a singleton module. So if you go into DQMH and you know, there is no possible way I will ever want more than one instance of this running, if you make it a singleton, your life will be easier when you're debugging. If there's any possibility you might want to be able to spawn multiple someday, you can create a clonable and just for the time being, always run it as a singleton. Excellent. Anything else?
Yeah, on the learning content, there's one thing you missed. There's the DQMH badge.
The DQMH what? The badge. I mentioned the badge earlier.
Okay.
Nate, if you had showed up on time, you would have heard.
I was in closed door.
Any other questions? All right, y'all. If y'all have anything you want to come up and talk to me afterwards, let me know. Thanks so much.